Good morning, students. In today's class, we are going to solve some more problems on CG, that is center of gravity problems. In the previous class, we have solved simple problems wherein we had only combination of rectangles in the given figure, but in today's class, we shall take up the different geometrical figures. Yeah, so in this problem, as you can see, the section is a combination of a right angle triangle along with semicircle. Now, we have divided the given section into two different diagrams. That is, one is a right angle triangle and the second one is a semicircle. So we can see that we have the reference y-axis and you have the reference x-axis, with respect to which we are going to find out the CG. So the first work is divide the given section. So we have already divided it into two geometrical figures. The next thing is we are going to form a table wherein we are going to enter all the details in the table, that is area of that specific figure, individual x bar, y bar, and finally calculation of the CG. So the first diagram, as you can see, it is a right angle triangle. It is a right angle triangle whose area is being calculated here. That is half base into height. So half base is given here 80 mm. Height is also 80 mm. Height actually is not given here, but with the help of this semicircle, with the help of this quadrant of a circle, you should be able to identify what is the height. So since the radius of quadrant of circle is 80 mm, the height of the triangle is also 80 mm. So sometimes the data will not be given directly. We are supposed to calculate it as in this case. So thereby we have written it as half into base into height, which is 3200 mm square. Now the next part is x bar, x bar. Now, as soon as you divide the given section, the next thing is you're supposed to indicate its individual centroid. So the individual centroid of triangle lies somewhere here, whereas the individual centroid of semicircle lies somewhere at this point. So next we need to calculate x and y coordinates. So the first one is triangle x bar of triangle. X bar is always calculated from y-axis. So distance of this centroid from y-axis. What is the distance of this centroid from y-axis? So the distance between the y-axis and centroid is 2/3 of 80, because you're measuring it from the apex of the triangle. So this is the apex. This is the apex. So from apex, CG of triangle is 2/3 of total length, that is 80. So it is 2/3 of 80. 2/3 of 80. Now next I want the y bar of triangle. So y bar is measured from x-axis. It is measured from x-axis. So the distance of this centroid or CG from x-axis is 1/3 of height. Why 1/3? Because we are measuring it from the base. So you can see that this x-axis is touching the base of the right angle triangle. Thereby it is 1/3 of total height. Total height is 80 mm. Therefore it is 1/3 of 80. 1/3 of 80. Now next we will be calculating the same for semicircle. Quadrant of a circle. Quadrant of a circle. So area of quadrant of a circle, we know it is pi r square by 4, where r is 80 mm. 80 mm. So 80 square divided by 4. Pi 80 square divided by 4 will give you the area. Next, you should calculate x bar and y bar of quadrant of a circle. So first is x bar. X bar is always measured from y-axis. Y-axis. So what is the distance of this centroid from y-axis? It is 80, which will get me to the face, that is 80 plus distance between this face and CG. We have already derived it. It is 4r by 3 pi. So distance between the face of the quadrant of a circle and the CG is 4r by 3 pi, where r is 80. R is 80. So it is 80 plus 4r by 3 pi, which works out to be 113.953. 953. Now the next thing is y bar. Y bar. Y bar is to be measured from x-axis. X-axis. So the distance between this axis and CG. Distance between this axis and CG. Again, since it is measured along the face of quadrant of a circle, the distance between this CG and the axis is 4r by 3 pi. 4r by 3 pi. So it is 4 into 80 divided by 3 pi, which is 33.953. 953. Now next, you have to calculate area into x bar, area into y bar for triangle as well as semicircle. So you can see here ax, it is this into this and this into x, that is ax. Next you have ay. What is ay? It is area into y bar, area into y bar. So area into y bar. So you will get ay. Now next, what we do is we add triangle and quarter of a circle. Now the reason why this summation of a, we are adding both the areas, is by adding triangle and semicircle only we get this diagram. Now there are some diagrams wherein deductions also will be there. We will take up it in the next problem probably, but in this case, by adding triangle and semicircle, we are getting the given section. So we have calculated sigma a, we have calculated sigma ax, we have calculated sigma ay. So finally x bar is sigma ax divided by a, that is sigma ax divided by sigma a. Next, y bar is sigma a y divided by sigma a, which will give you the answer. That is x bar is 90.373, y bar is 31.119, which is being shown in the diagram here. So x bar is measured from y axis. You can see here. So this is x bar which is measured from y axis, So x bar always measured from y axis, and y bar is always measured from x axis. So you can see this is the x axis and this is the y bar. So the intersection of both these lines, is the CG of the total section. Now, let us move on with the next diagram. Bit typical one, but very simple. Yes, so this is the diagram. Have a close look at the diagram. In this diagram, you can see that there are 4 numbers of common geometrical figures which can be formed. That is right angle triangle, rectangle, semicircle, and a circle. But what is to be noted here is this circle is a cutout. It is a cutout in the sense you're supposed to deduct this part. You're supposed to deduct this part in the calculation. In all this problem you saw, in this problem there was no deduction any such. So triangle plus semicircle. But here in this problem there is a circular cut. There is a circular cut. So when you differentiate this into four diagrams, the circle will be a deduction there. Circle will be deduction. Hence, it will be taken with the negative sign. It will be taken with the negative sign. What will be taken with negative sign? Only the area will be taken with the negative sign. You can see here. It will be taken with negative sign. We know that this is reference y-axis. This is reference x-axis. Reference x-axis. So, since it is lying in the first quadrant, all the x bar and y bar will be positive. Now, before proceeding with the problem, I have told you one thing. You are supposed to individually mark the CG of all the geometrical figures. So there are four figures here. First one is rectangle, second one is semicircle, third one is a right angle triangle, fourth one is a circle. Let us mark the CG of these individual figures. So first one, rectangle. Where does CG of rectangle lie? It lies exactly at this point. Coincidentally, circle CG also lies at the same point because it is exactly located at the center. It is located at the center. Next, you have a semicircle whose centroid lies somewhere at this point. Somewhere at this point. That is very close to the diametrical axis. Keep in mind, very close to the diametrical axis. Next, you have the third one, right angle triangle, whose CG lies somewhere at this point. Somewhere at this point. And the fourth one is a circle whose CG already is being shown here, which coincides with the rectangle. So the first diagram is a rectangle. We need to write the area of rectangle now. What is area of rectangle? So it is 60 plus 60, 120. 120 by 100. So 120 by 100, which is 1200. 12,000. 12,000. 12,000. Next, I want x bar. X bar of a rectangle. X bar means you're supposed to measure it from y-axis. Y-axis. So this distance between the individual centroid and y-axis is b by 2. B by 2, which is 120 divided by 2. That is nothing but 60. 60. Similarly, the next part we are going to calculate y bar. Y bar. So in y bar, you're going to measure the distance from reference x-axis. X-axis. So from x-axis to individual CG, it will be d by 2. That is 100 divided by 2, which will be 50. Which will be 50. Now, in the next part, second diagram, that is semicircle. So, distance of this CG, that is of semicircle from y-axis will give me x bar, So, distance between y-axis and CG of semicircle. From this axis, 120 mm will get me to the diametrical axis of semicircle. So it is 120 plus the distance between the diametrical axis of semicircle and the CG. We have derived it, that is 4r by 3 pi. 4r by 3 pi, where r is 50. R is 50. So it is 4r by 3 pi. 4r by 3 pi. So you will be calculating the distance 120 plus 4r by 3 pi, which will give you the x bar of semicircle. Now next I want y bar of semicircle is measured from x-axis. So we have already discussed the distance between x-axis and cg in this orientation of semicircle. It will be d by 2, where d is the diameter of semicircle. So diameter of semicircle is 100. So it is 100 by 2, which is 50. Next, you have the third diagram. That is right angle triangle. So the distance of right angle triangle CG from y-axis will give me x bar. So the distance between this reference y-axis and the CG of a right angle triangle is one third of the where length is 120. Why one third? Because we are measuring it from the base of the triangle along its width, that is 120. So from base it is one third, therefore it is 1 by 3 of 120. Next, I want the distance of this CG from x-axis, which is y bar, y coordinate of right angle triangle. So the distance between reference x-axis and this CG is 100. 100 will get me to the base of the triangle. So from base to CG, it is one third of height, and here the height is 60. So from reference x-axis to CG of a right angle triangle, it is 100 plus one third of 60. So this will give me the y coordinate. Once we get x and y coordinate, we can easily calculate the required data. In the next fourth one, we have a circle. So in circle area of a circle, it is pi r square, but since it is a deduction, it is to be taken with the negative sign. So in this, okay, so the fourth diagram is a circle, and since it is a deduction, the area is written with the negative sign. So always we should keep one thing in mind: whenever there are deductions, the area of that specific figure is to be written with the negative sign. So it is minus pi r square, where radius of a circle is 20 mm. So it is minus 20 square. Now next I want x bar and y bar of a circle. So x bar is measured from reference y-axis. So the distance of the centroid of circle from reference y-axis, it is nothing but 60. So you can see directly the dimension is given here as 60 mm, therefore we can denote it as 60 directly. Next I want y bar. So the distance of the centroid from reference x-axis, so it is 100 divided by 2, because the distance between the CG and reference x-axis is 100 divided by 2. 100 divided by 2, because the circle is lying exactly at the center of the rectangle. So it is 100 divided by 2, which is 50. Once we have calculated the area, x coordinate and y coordinate, we are going to calculate ax and ay. ay. So a into x, you have it in this column. A into y, we have it in this column. But one thing to be kept in mind, one thing to be kept in mind, this circle, that is the fourth one. So if you have a look at the ax and ay of the fourth diagram, it is with negative sign. Why? Because it is a deduction and the area is taken with the negative sign. Negative sign. So it is minus 1256.64 into 60, which will give you minus ax, that is ax, and ay. So finally summation. So summation of area will be 12,000 plus 3926.9 plus 360 minus 1256.64, which will give me 8 18,270. Similarly, ax, considering this negative sign, will give me 13,43,171. Similarly, ay 11,65,517. And finally, I'll be able to calculate x bar and y bar by applying the formula sigma ax by a, sigma ay by a, respectively. So this completes the problem. This completes the problem. So in this problem, we saw that there was one figure which was with the negative sign, and it was taken with negative sign in the area. So this is what is to be kept in mind. So this negative sign plays a very important role here. Very important role here. So with this, we have completed the problem. We have completed the problem.